Good everyone. In today's class, we're going to continue from where we stopped in our previous class. Okay, so we are still solving questions on functions. Okay, so we are starting with this question today. This is the function f of x is given to be this, yg of x is given to be this, and this is the domain. Okay, so the diagram shows part of the graph y equals f of x. Don't forget this is f of x. Then state the domain of f inverse of x. State the domain of f inverse of x. So when you look at this question, you can see it's 1 mark. So don't stress yourself by looking for the inverse of this function before you get the domain of inverse function. So it's very simple. Remember we said that domain of function f, domain of f is same as what? Range of f inverse. Then likewise the range of f equals domain of what? Domain of f inverse. So since we are to find the domain of f inverse here, it means that this is equivalent to the range of f. Okay, so now we can easily get the range now looking at the graph that we have here. Okay, so when you look at this, we have two curves here. So to get range, remember we consider that to be y as x. Okay, your domain is on the x-axis. Is that taken out? So we use y-axis to determine the range. Now when you look at this, the two curves here converges to this line. If you look at the line carefully, so the two curves that we have here converges to this line. Can you see that clearly? And this line here, since this is 2, of course this is line y equals 1. So it means that the two line converges to y equals 1. That is, the range of f now is set of real numbers, but not equals to what? Not equals to 1. So I'm using x here because we are talking about domain of f inverse. So yes, like I've said, that the range of f is same thing as domain of f inverse. So it means that the domain of f inverse now is set of real numbers but not equals to 1. Ordinarily, if you are looking for the range of f, you just write y belongs to real numbers but y not equals to what? 1. Okay, so but since you are now talking about domain of f inverse, now we use x. Exactly. So that's the answer to the first one. So domain of f inverse equals x belongs to real number and x not equals to 1. So b, find inverse of b. Find inverse of f. So remember f is given to be, f of x is given to be 2x plus 1 over 2x minus 1. So to find inverse of this function, represent that to be y as usual. So you have 2x plus 1 over 2x minus 1. Then you simplify this by making x as a subject. So if you cross multiply here, you have y in bracket 2x minus 1, then 2x plus 1. So expand the bracket, 2xy minus y equals 2x plus 1. Alright, so this is 2xy minus 2x equals 1 plus y. Exactly. So factorize x, now you have 2y minus 2 equals 1 plus y. Then divide both sides by 2y minus 2. So you left with 1 plus y over what? 2y minus 2. So for that reason, f inverse of x now is x plus 1 over 2x minus 2. And that is the inverse of f. Now next thing is to find g inverse of 3. So since we've gotten inverse of f to be this, so f inverse of 3 now will be 3 plus 1 over 2 times 3 minus 2. Exactly. 2 times 3 minus 2. And this is 4 divided by 4, and that will give us 1. So now we put that in g inverse of 3. So this is g of 1. Where g of x, what do we have as g of x? I think is this is g of x, x squared plus 4. So 1 squared plus 4, and this is 5. Okay, so that is the solution to that. Then D, explain why G inverse of x cannot be found. Sorry. Okay, so what's G of x again? We have G of x to be x squared plus 4. Now when you look at this, do we have domain for G of x? What's the domain of G of x? Set of real number. Quadratic function, generally, if you consider that to be set of real number, if you consider domain to be set of real number, quadratic function is many to one function. And we said for inverse function to exist, then the function must be 1 to 1. So since this function now we have here with this domain is many to one function, okay, so it implies that the inverse of many to one does not exist. That's what it means. So just write since g of x equals x squared plus 4 with this domain is many to one function, is many to one, and the inverse of a many to one function does not exist. Okay, so does not exist. So, and that is that question. So moving to the next question. So let's move to the next question. But then again, before we move to the next one, you can actually show this on graph to let them know that you understand what you are saying. Okay, so x squared plus 1 is translation of x squared with vector 0, 4. It means 4 units up. So you have something like this. This is what you have. Let's say this place is 4. So looking at this now, you can see the curve here is many to one function. Okay, so moving to the next one. The function f is defined to be this, and the domain is x less than minus 3. Express f of x in form of this. Okay, yeah, to complete the square, we already know that we need to ensure that coefficient of x squared is 1, and the only way to do that is by factorizing the minus 2, which is the coefficient of x squared. By the time you factorize minus 2 from the first two terms, you will left with x squared plus 4x. Then minus 13 is outside. We need to isolate minus 13. So now you have minus 2. Divide coefficient of x by 2. That becomes x plus 2 squared. Then minus, there should be brackets here, minus 2 squared. Then minus 13. Alright. So you expand the brackets, minus 2x plus 2 squared. Minus 4 times minus 2, that's plus 8. Minus 13. And you will finally have minus 2 in bracket x plus 2 squared minus 5. Now next thing, find the range of f. So to find the range of f, remember that function is a quadratic function. So just take it from the result you obtained there, which is minus 2x plus 2 squared minus 5. When you look at this now, the turning point here, turning point of this function, which is also the maximum, is the maximum because the coefficient of x squared is negative. So the turning point there is minus 2, minus 5. Okay, which means the maximum value you will get here is minus 5. Okay, but we have to consider the domain here. Domain is x less than minus 3. X less than minus 3, like we always say that before you can choose the turning point, I mean the maximum as your maximum value or minimum points as the minimum value, the domain, the turning points must be included in your domain. Okay, so when you look at this, the turning point you have here is minus 2, and of course x less than minus 2, minus 2 here that we have is outside this domain. Okay, it's outside this domain. So this is exactly what we are saying. Let me represent this in graphical form. the parabola looks like this. It's going to look like this. Okay, so where this very point here, this particular point here is minus 2, 5, and we're talking about x less than 3. So let's say this is a real line. Now for you to have minus 2 here, minus 3 must be around this place, and you can see this is going to be outside. Minus 2 is outside the domain. So what are you going to do now? You cannot choose this as your minimum or maximum again, so you just use direct substitution. It means that when x is minus 3, you get the maximum value for that. So put minus 3 there. That's minus 2 in brackets, minus 3 plus 2 squared, then minus 5. Okay, and of course this should give us what? That should give us minus 7. So which means the range here is f of x less than what? Minus 7. Okay, you don't use less than or equals to, because what you have here is less than. Okay, yeah, next thing is to find the inverse of that function. The inverse of that function, we continue from where we stopped here. I mean from f of x equals minus 2 x plus 2 squared minus 5. Okay, so represent this to be y. So we have y equals minus 2x plus 2 squared minus 5. So make x as the subject. So y plus 5 equals minus 2x plus 2 squared. So you divide both sides by minus 2, and this becomes y plus 5 in brackets minus over 2, then x plus 2 all squared. So next thing is to take square root of both sides. So x plus 2 equals square root of minus y plus 5 divided by 2. Now down to the question of anytime you are taking plus or minus, taking square root, you must include plus or minus. But remember, we obtained the domain there to be what? The domain is given to be x less than minus 3. And for x to be less than minus 3, it means that x plus 2 must less than 0. That's what it means. So what are we going to do here? We choose plus or negative. Since x plus 2 is negative, then the right hand side here must also be negative. So x plus 2 equals minus root minus y plus 5, then over 2. So x equals minus 2 minus y plus 5 divided by 2, which means f inverse of x now is minus 2 minus square root of minus x minus 5 divided by 2, and that is the solution to the given question. Okay, so we stop here for today, so we continue from the next class. Thank you.